to our speaker, Mussie Beyene came to Maine in, I've forgotten, in 2011, and he's a PhD student in civil engineering, and his undergraduate degrees from University of Asmara in Eritrea. So, we'll see.
So my name is Mussie. I'm a PhD student at Civil and Environmental Engineering. Today's talk will be based on publication with my advisor, Professor Jane, on this topic. So, but before I start with the climate and lake ice part of it, let me just give you an idea about what's the impact of lake ice on Maine lakes. So, as you may all know, Lake Auburn is a lake found in southern Maine. Historically, it has never had any water quality issues, and it hosted diverse cold water fishes. But in the fall of 2012, suddenly the lake turned to green due to algal blooms. Also, the cold water fishes that were in the lake died. And according to Williams, in his report regarding the future state of Maine lakes, he said that one of the triggers that brought about this event was that the ice season ended 1 month early. Now, when this 1 month early. Now, the early end of the ice season, combined with higher spring temperatures, brought about early stratification. To all of you who don't know what stratification is when the top part of the water doesn't mix with the bottom part. So because of that, the oxygen level in the bottom lake, in the bottom waters, will be fixed. Now, because the stratification period in this event increased by 1 month, the oxygen level inside the bottom level was exhausted, and anoxic condition or lack of oxygen condition occurred during that time. When that happens, all the cold water fishes that lived at the bottom of the lake died out of lack of oxygen. Also, these anoxic conditions also brought about the release of phosphorus, which was in the sediments. Now, this release of phosphorus in the sediments, combined with the increase of phosphorus from outside of the, the outside within the farms due to higher rainfall, this brought about algal blooms, or it turned the lake to green. Now, of course, it's not just because this thing happened, just because there was an early ice out date during that event, but it was one of those factors. Also, what I realized from that incident was that lake systems, when we analyze lake systems, we should always think of thresholds, that the relationship between stressors and lake systems is not incremental or linear. There are thresholds and it's non-linear. At one point, the lake can change from a clear lake into a green lake. Also, the change in the ice season has an effect on the socio-economic. It has a socio-economic impact. As you may know, in Maine there are about 50 to 100 ice fishing derbies, and in 2010, in 2012, in 2016, because of warm winter temperatures, it was unsafe for people to go to these lakes and do their winter activities. So basically, the change in ice season not only impacts the revenue that people get when people from outside come and do their winter activities, but also changes the way that people interact with the lakes. So, by definition, ice out date refers to the time that the winter ice completely disappears from the lake surface. So, and then the focus of this study is thus to characterize, if any, the relationship between winter temperatures and ice out dates. And the second focus of this paper is to analyze the role of large-scale climate patterns on winter temperatures and ice out dates. Now, there are about 5,000 lakes and large ponds in Maine. And so that you can understand, and with the exception of few lakes, lake ice completely covers this lake. So that you can understand what the lake formation, growth, and decay is, I simulated the ice thickness of Lake Auburn and Lake Portage, which is found in the northern part of Maine, and then for the year 2006. As you can see, most of the growth in ice occurs during January to February month. Now, during those times, the rate of ice growth is high when you have when your daily temperatures are below zero, which is the blue area that is that you see in that table. So and when and the area under the blue area is also called accumulated freezing degree days, which is the sum of the degree days below freezing over the number of days that was below freezing. And the red area that you are seeing right now is also called accumulated melting degree days. It refers to the degree days that were above 32 degrees. So when you see the growth of ice, whenever you have more of the blue color, the rate of ice growth increases. And when you have more of the red color or more of the winter MDD, then you'll have your rate of ice growth decreases. And as you can see, because Lake Portage has a large number of winter FDD and less number of winter MDD, you'd see that the thickness of ice for Lake Portage is about 80 centimeter, while for Lake Auburn it was about 30 centimeter. Now, in the period between March and April is a time that the the ice decays. And depending on whether there was, depending on also, just like the winter conditions, if you have more of the AMDD and less of the AFTD, then the rate of ice melt is high. On the contrary, if your winter AFDD is higher, then the rate of melt will also decrease. So, as you have seen earlier, because in the southern regions, because there is a higher amount of freezing degree days and less amount of winter degree days, you see that you have higher thickness of ice. Also, because spring starts later, then even the rate of melt is it occurs later on. So as you can see, most of the lakes found in coastal and southern lakes, their ice out dates is it happens between April 10 to April 20, and those lakes that are found in the northern parts or the western part of Maine, their ice out occurs sometime in May. Now, aside from the regional difference in the ice out days, we also see a large variability of ice out dates. And recently there has been an increase in the occurrence of early ice out days. And according to Hodgkins, who studied New England lakes, he said that this increase in the frequency of early ice out dates was due to the trend or the change in the mean ice out dates. Also, he said that the increased incidence of early ice out dates was due to the average March and April temperature. However, although he just looked at it like he looked at the increase in the frequency of early ice out dates by the change in the mean, a change in the variance itself, in the interannual variance, can bring about an increase in frequency of early ice out dates. The figure that you see is modified from the IPCC. As you can see, an increase in the mean can bring about extreme events. Also, an increase in variance can also increase the incidence of extreme ice out dates. So we don't know why he didn't look at the change in variance also. Also, when he said that most of the variability in ice out dates in Maine was due to March and April temperature. But when you look at the ice out days of coastal and southern lakes, most of them are occurring in March 15 or late March. So if it is the average temperature of March and April, then how is it that the ice out days is happening in March? So it doesn't, I mean, for those events that are occurring recently in most of the coastal lakes, March and April temperature doesn't explain anything. Furthermore, the average March and April temperatures cannot be predicted at the current moment. So even if you have models that relate ice out dates with March and April temperatures, you cannot predict it, or you cannot say what's going to happen, because there is no mechanism by which we can say during next year March and April temperature will have this amount of temperature or this amount of deviation. Now, in the temperate regions, as you know, the winter temperature conditions in most of the temperate regions is influenced by the El Nino pattern. For example, this winter we had a warm winter because of the tropical Pacific being warm, or the warm, when we have the warm phase of ENSO, which is called El Nino. Because of that, we had a warmer winter, and ENSO by nature is a tropical Pacific sea surface temperature condition which oscillates between warm phase and cold phase, and it affects the temperature or precipitation conditions within the entire globe by reorganizing the large-scale climate patterns that affect the temperature conditions in all over the globe. So what we thought was that, if we could identify a climate pattern which is also influenced by ENSO, and if we can relate that with the ice out dates, then we can, because El Nino events can be predicted 6 months or even a year ahead of time, then that means that we can also predict ice out days even 6 months or a year ahead. So we tried to, so we identified a climate pattern called tropical northern hemisphere pattern. Now, in this, when this pattern largely affects the north central and northeast of North America, as you can see, when the TNH pattern is in the negative phase, then you can see that most of the north central and Canada, eastern Canada and Maine have a higher temperature. On the other side, when TNH is on the negative phase, then you can see that the north central and also some part of the eastern Canada get cooler temperature. So, and then we looked at how when TNH is in the negative phase or TNH is in the positive phase, you can see that there is a deviation. Like when you have negative TNH pattern, you'll have a higher winter temperature, and when you have positive TNH pattern, then you'll have lower winter temperature. Also, what I have not mentioned is that this TNH, this negative phase of TNH, is related to El Nino. It's associated with an El Nino pattern. So, if we can, if we know that there will be an El Nino pattern, then it is associated with the negative pattern of TNH, and this can be related to warmer winter conditions in Maine. So to understand this role of winter climate variability, we looked at the earliest 10 ice out events of 8 lakes from 1950 to 2010. And then we selected those 10 years. Then we said, okay, if it is so that to represent the trend only, we said, okay, let's take the latest 15 years between 1996 and 2010 and count the number of these early ice out events. And then we also took 15 years where the TNH was in the negative phase, and then we said, okay, how many of those early ice out events occurred when TNH is in the negative phase? And as you can see, when because of trend, which is represented by the most recent years, you can see that 40 out of the 80 ice out events occurred during the period between 1996 and 2010, which represents that because of trend, you have a higher likelihood of early ice out events. But also what you can see here is that when TNH is in the negative phase, 41 out of the 80 early ice out events also happened. So what this, and what's remarkable about this is that TNH was in the only 3 years out of the 15 years was in the period between 1996 and 2010. So what this result indicates is that trend not only, it's not only trend that has an influence on the frequency of early ice out events, but also the interannual variability in winter climate also has an effect on the frequency of early ice out events. So to determine the winter degree days, the relationship between winter temperatures and ice out days, what we did is we first plotted the accumulated freezing degree days and the accumulated melting degree days of all the 61 years for Lake Damariscotta. Then we said, okay, what is the winter? What is the characteristic winter degree days for those years when we had early ice out events? Then we compared that degree days property to the degree days property of all those that had later ice out events. And as you can see, there is quite a distinction between the winter degree days for early ice out events and then those that had later ice out events. If it was, as Hodgkin said, if it was only March and April that had influence on the ice out events, then we would see that the blue and the red colors would have been overlain with each other. But because we see that there is a distinction, this shows that winter temperatures affect the ice out dates. Furthermore, by looking at the winter degree days for those that had early ice out event, you can see that below a certain degree days, you have a higher probability of an early ice out event. And then also, if your winter degree days is above a certain threshold, then you have a higher likelihood of later ice out events. So now that we determined the winter degree day thresholds that bring about the early and later ice out events, then we looked at the relationship between negative TNH and winter temperatures. And as you can see, so we generated the probability, the winter AFDD distribution for the negative TNH phase and the other years. And as you can see, there is a shift towards lower winter AFDD during negative TNH years, and also there is an increase in the winter AMDD for Lake Damariscotta during positive, non-negative TNH years. So, so based on the relationship between negative and the temperature, then since we already identified the winter degree days thresholds in the previous plot, we then said, okay, we know that for Lake Damariscotta, 600 degree days Fahrenheit brings about early ice out events. So we said, okay, what if it is, what's the likelihood that when TNH is in the negative phase, we will have an early ice out event? And from the result, it shows that there is a 150% increase in the likelihood when likelihood of an early event when Lake Damariscotta is in the negative TNH phase, and also there is less than 70% chance of later ice out events when TNH is in the non-negative state. Now, in conclusion, lake ice not only has, if you look at other studies, lake ice has an effect in water temperature, in the food web. There are so many aspects that ice season affects. So, but on Friday I was reading the paper by Canfield regarding the water quality, the change in the water quality in Maine. So I was looking at it, and they said that this fluctuation in the Seki depth was due to precipitation, and I mean there is that physical explanation that indeed precipitation can bring about an early ice out event. But if you look at those years when the water quality of Maine lakes was at a lower Seki depth, you can see that it was also during the years when we had an early ice out events for those years also, for Maine lakes. And also, if you look at the SST conditions in the tropical Pacific, you'll see that out of the 6 early ice out events, 4 of them had the SST pattern in the tropical Pacific was warm, or it was an El Nino condition. So basically, if we can relate ice out dates with water quality, then this indicates that that based on the relationship between El Nino and ice out dates, then we can speculate about the future state of Maine lakes. Thank you.
If plenty of time for questions. So
this is groundbreaking research, and so obviously we're still in the early phases of understanding these sort of things, but are there any solutions that could be applied locally towards combating these negative effects of early ice updates?
To combat?
Yeah.
To combat the effect?
Yeah.
Of course, I mean, if we can, I mean, like, there are, say, for example, you can do aquatic biomanipulation. Like, for example, if you think that you will have an early ice out event, and you would have water quality issues, people have used biomanipulation to change the state of a lake. So, yeah.
others.
I'm wondering if you've looked at other atmospheric patterns and associated.
Exactly. I have looked at other patterns. The only reason that I've showed you this TNH pattern was because it is associated with El Nino, and you can predict it because there is a relationship between the state of the TNH and El Nino. You can predict it. But also, I have found out that in my paper that North Atlantic oscillation also has an effect. But then the problem with North Atlantic oscillation is that you cannot predict it season ahead. But with El Nino, because it evolves very slowly, you can predict what is going to happen in winter just by looking at the summer temperatures of the tropical Pacific. So that's why I only talked about the TNH pattern. Also, I tried to take a lot of science out of the climate science. I mean, I tried to make it as accessible as possible, but there are lots of things that I didn't really.
Can we expect the type of the effect of El Nino, like what you said in the tropical Pacific this year? There is a rising in the temperature, so we got a warm winter. So does this effect usually are the same, or we can get opposite effect, like if rising there, so maybe we can get like a
Colder.
winter.
Of course, it's atmosphere.
So how can we expect that?
So that's why you have a probability distribution. You say, okay, when I have an El Nino event, what's the chance that I will have a cold event? It doesn't necessarily mean that you will not have a cold event. You might have, because it's an atmosphere, you can have a cold event. But then there is a higher chance that you'll have a warm event in Maine or
Other questions for?
How early does an ice out date need to be for it to be considered like a severe instance? Like at what point is it starting to be like dangerous or going to cause problems in the lake?
so it depends on you. For example, if if you say, for example, for the Lake Oban, for example, we saw that when the lake ice date ended 1 month early, then we saw that it brought about a lot of change in the water quality and other aspects of it. So for you, you can say, if my ice out date is within this range, then that means that I should be careful, and I should try to find what are the conditions that bring about this event. So it depends on the kind of relationship that you can establish with that.
Right, well, if you have no